Hey everyone, my name is Scott, and today we're going to solve the unique Morse code words problem on LeetCode. Here's the problem description. It says, International Morse code defines a standard encoding where each letter is mapped to a series of dots and dashes. And it looks something like this. So an A is mapped to dot dash, a B is mapped to dash dot dot dot. The actual encoding is not that important for us. It's all laid out right here as far as how the alphabet maps to dots and dashes. So we're given a list of words, and each word is obviously a concatenation of Morse code for each letter in the word. And we want to know the number of unique Morse code encodings that there are in the words that we're given. So look at the example here. We're given the words in English characters, gin, zen, jig, message, okay? And here's what each of them looks like when they're transformed into Morse code. And the output is 2 because obviously you have the same transformation here and then the same transformation here. Gin and zen both map to the same Morse code. Jig and message both map to the same Morse code encoding. So how are we going to do it? Well, one of the things you need to realize is whenever you're trying to remember things that you've seen before, a hash set or a hash map is always going to be really important, okay? Because that's going to allow you to look up and remember if you've seen something in constant time, which is really big in problems like this. So one of the things I've copied to my clipboard right now is just a array representation of the Morse code encoding, because it's just a lot to type out. So what we're going to do is set up this array called Morse, which is going to hold the encodings from a character to its Morse code encoding. So, like I said, we're trying to remember if we've seen something before, and whenever you want to know if you've seen something before, if you're trying to track things that are unique, you're going to want to use a hash set or a hash map of some sort. Here, we're going to have a hash set of strings called scene. We're just going to make that a new hash set. Now, a set here is a set in the mathematical sense where all of its entries have to be unique. Okay, there will be no duplicates in the set. We're going to loop through our input. Pull out a word. And we're going to use a string builder to build up its Morse code encoding. There are different ways to do this. The string builder is just the easiest way, particularly if you're using Java. And what this will do when we instantiate a new string builder, it basically just gives us an empty string builder at first that we can build onto. We're going to loop through the characters in our chosen word, the word that we've pulled out of our input. And we're going to call this method append on our string builder, which lets us append a string to the end of this current string builder that we have. And what are we going to append? We're going to append the entry in our Morse code array up here, which, as you may have noticed, is an array of strings. And which one will be? It'll be C, which is the character that we currently have, minus A. Now this is a little tricky and deserves a little explanation, because this is something that once you understand is really helpful. We're going to come back to that because the code's almost done. Then we're going to add into our hash set the builder that we have, we're going to call toString on it, which takes your string builder and just turns it into a Java string for you. We're going to return scene.size. Let's make sure that all that works, and then we're going to step back and go through the more difficult, tricky bits there that deserve some explanation. Alright, accepted solution. Cool. So we know this works, but let's explain some of this stuff really quick. Again, we're using a hash set because we need to know if we're looking for unique things. What the hash set lets us do is know in constant time whether or not we've seen an entry or not, an object that we're querying it with. Now this bit right here, you may have noticed up here, this is obviously a string array, a Java array, of these Morse code representations of characters. Now this is obviously zero based, okay? Here's the 0th element up through the 25th element. So if you haven't seen something like this before, what we're doing is, this is a character, C right here. He's a character in Java. Now, characters in Java can also be represented as integers, okay? And what we're doing right here is a little bit of clever math. What Java is doing for us under the hood, you may look at this and say, this is a character, C, and we're subtracting the character A from it. That doesn't make any sense, right? There's two characters. How do you subtract a character from another character? Well, I have the ASCII table pulled up right here. Now, what Java's doing for us here is it's taking this subtraction operator and it's saying, okay, they're doing a subtraction operation and the operands are two characters, okay, two character types. And what it's doing for us is it's interpreting it and it's casting implicitly this C, this character C, it's casting it to its integer representation, and this character A, it is also casting it to its integer representation. And it does that math for us. It subtracts the two integer representations from each other, and that is the index that we end up indexing in Morse. Now let's look at the ASCII table and see why subtracting A works. Here's the ASCII table. Here is lowercase a. Okay, lowercase a decimal representation is 97. Now you'll see this is lowercase a and it runs all the way sequentially through lowercase z. Okay, so whatever character we have, be it lowercase a through lowercase z, and that was one of the restrictions on the input we were given, was that it will consist of only lowercase letters. So we know all our input is lowercase a through lowercase z here sequentially. So what happens is, let's say we have D. Let's say the character we're looking at is D. His decimal representation is 100. Well, when we subtract A away, we subtract 97 away, 100 minus 97, that takes us to decimal 3, okay? Don't bother with the character representation here. The point is that when we subtract away A, we get to basically a zero base, okay? By subtracting A away, let's say it's A minus A. 97 minus 97 is 0. Excuse me, 0. Okay, so let's say this character right here, let's say the C is A. Let's say it's actually A. Then we would be doing 97 minus 97, which would get us to 0. And then 0 in our Morse array is this guy right here, which is the representation of A in Morse code. Okay, and the way we set up our array, it goes A, B, C, D, E. So since it's sequential like that, all this math will work out. So again, let's say we look at B. It'll be 98 minus 97, leaving us with 1. We get an index of 1 into our array, which has the representation of B right here. Okay? So this is really tricky at first. The first time you see it, it doesn't make a whole lot of sense, and it's a little weird. But once you start understanding the ASCII table, okay? First off, you have to understand the ASCII table. Now, depending on what characters you're working with, you may not know what their indexes are. A lot of people get so good at using this stuff that they just know that, hey, lowercase characters, A starts at 97, and everyone's, shut up, phone. Everyone's just sequential after that, right? So just remember this ASCII table. This is just ASCIItable.com, where you can come look at this stuff, and it'll show you their decimal representations. And once you start understanding how this works, you can start using this in a lot of powerful ways. Instead of needing, say, maybe we needed a hash map. Maybe if we didn't know this trick, we would have set up like a hash map and said, character A maps to string ... character B maps to string ... okay? We didn't need to do all that. Since we know about this little trick here, then we can just use an array and index it this way. And then one quick more bit that might need a little bit of explaining here is all we're doing with our hash set called scene is we are adding the string representation of that Morse code that we just built each time. And that may not look right at first, right? What if we end up with a string ... okay? Let's say we get that string, and we get it twice. Well, what you might look at here, you might say, well, we just added it twice. We're counting duplicates. This isn't right. Well, the hash set, the data structure in Java scene, the hash set, it, like I said, is a set in the mathematical sense. And when we call add with something that it's already seen before, shut up, phone. Let's see we give it a duplicate, right? If we give it a duplicate, then it will simply sort of reject this operation. It won't add it, okay? So we are actually just counting the unique ones here. Only unique strings will be added to the hash set. A more explicit way of doing this, we could have done something like if scene dot contains or has, then we won't add it, else we would add it, or if not contains. This is just a little trick right here. So just remember, with hash sets, they will not allow a duplicate. So by just calling add, if you try to add something that it already has, it will not add it. So only unique values will ever end up in scene, our hash set. And that's why here at the end, we can just return scene.size. So that's it for this one. There's a couple, fun little tricks there. First off, you're using a hash set, which lets you query in constant time. We're using a little bit of tricky math here with our ASCII table and implicitly casting characters to integers to map into this string array that we have here. And then right here, the fact that hash sets are only going to allow unique values. Calling add. If we call add with something it already has, it just won't add it, and we're able to add size. We're able to return the size here and get the right answer for the unique Morse code representations. So that is it for this one.